unmuting your microphone or through the chatting, okay? I will try to answer any questions that is related, okay? Don't ask about my age or my wife. I'm already married. Okay, so we will start with today's lecture, BMM3613, Automatic Control. Okay, so my name is Muhammad Jamin Muhammad Motaruddin. You guys can see the screen, right? Okay, so how to contact me? You can contact through WhatsApp. Okay, that's my number, and through email. And if you want to see me, you can come and see me at UMP, Block 3, Bengkel Creator AC. Okay, Bengkel Creator, okay, level 1. Okay, so this subject is 3 credit hours, section 1. You guys are section 1. On Monday and Wednesday, 8 to 10 a.m. Okay, so persoalan, is this subject senang atau susah? Okay, we will come back to this question later, okay? Okay, so in this subject, there are 3 course outcome, okay? So course outcome meaning that what you will achieve throughout this course, okay? So the first course outcome, CO1, is you will be able to evaluate the basic control system concept and illustrate the required control system into block design process. And then second one is you will be able to develop frequency domain transfer function of linear time invariant control system for mechanical system. Okay, so this subject focus on mechanical system. Maybe previously, maybe around 5 years or 6 years ago, there is an electrical system component, but it's already been removed from this syllabus. Okay. And lastly, the course outcome is the ability to synthesize the transient response, steady state response, and system stability. Okay, so in automatic control, you will go through a lot of stability questions. Okay, how to determine stability of a control system, what method to use, and how to know from the system whether from the system performance whether the system is stable or not. So that's the essence of control system, the stability. So in this subject, it revolves around to determine the stability of a system. So for example, here using root locus and PID. Okay, there are a lot more methods, but here we focus on root locus and PID. Okay, in this course outcome. All right, so the content of the subject divided by weeks are shown. Okay, so this week we will go into learning basic control system concept. Okay, so today we will go into learning about basic control system concept, and in the next 2-3 weeks, we will go into learning dynamic system, how to model, and then after that, we will go into analyzing control system. So usually your midterm is from chapter 1 until chapter 2, maybe three the first section of chapter 3. Okay. And then chapter 4 is about root locus. Chapter 5 is designing controller from frequency response technique, such as bot plot. And lastly, we will go into PID controller design. So for your final later, all topics will be asked, okay, in your final exam. But for midterm, only topic 1, 2, and 3, the first section, the first subsection, okay, subtopic. And for the reference, I would like to suggest you to find the the first reference here, Normanese Auto System Engineering, because the lecture notes follows this reference. And then the second one is for the chapter 6, okay? And the other are not important, okay? They are just there to complete the reference list, okay? We are required to put 5 reference for you guys, but the most important are the first 2, okay? The remaining are not important. Okay, so assessment methods. So you will have midterm exam, 20%, and project plus quiz is total 40%. So for project, I will brief more next week, okay? So for project, basically you are required to use MATLAB, okay? So try to get MATLAB. And maybe project will be in group of 3, okay? Maximum 3. And then final exam is 40%. So all total 100%. And if our final is online, then it will be converted to 20% and the carry marks will be 80%. Okay. Okay, so for project and quiz, so it will be split into 25% quiz and assignment every week, okay? Starting this week, inshallah. And actually 15% actual project, okay? So this is 15%. 15%, okay? Project, I think it will be posted in Kalam, but I'm not sure whether we can access Kalam or not because I cannot access Kalam for the new semester. So later, I will maybe next week I will brief more on the project. Okay. Okay, so back to the question. Susah ke senang? Okay, kita tengok statistik for semester 1 2018-19. So kalau tengok dalam graph ni, if you look at this distribution of scores or grades, like more than half of students obtain C plus and below. Okay. So I know that you guys target to get A, but I want you guys to target to get this into this range, okay, from B minus to A, okay, because it's easier to get C plus and below, and even easier to get this E, okay. So if you get E, don't come see me again next sem, okay. Okay, this is sem 1 2018, 2 years ago. And this is last year, sem 1 2019-20. So the trend is the same. Okay. Here only one get A. Okay. And the reason why many students got C plus and below, simple. Okay. The reasons are simple. So first reason, because the class are face to face before. So some of them keep ponteng. Okay. So for our class, since it's online, you guys can ponteng the online class, but please watch YouTube, okay? Watch the YouTube video. Okay, I know maybe it costs you data, but not me to be blamed and not UNP as well. You need to blame COVID-19. Okay, and since we have quiz every week, so when you ponteng, then you don't answer the quiz. And since this is online class, maybe some of you will answer the quiz by copying your friends. So when you copying your friends, when your friends are doing it wrong, then you automatically get the same marks, okay? Very low marks. And please ask question if you have any question. Even stupid question like what is automatic control, I will try to explain, okay? Don't be afraid to ask question. If you are afraid, then not my problem, okay? It's your problem because the question will keep playing in your mind, okay? So please ask me questions. And if I give you a tutorial or exercise, please try to do it yourself first, okay? Before copying from your friends, okay? In education, in study, I believe that copying friend is a method to study, but it's important for you to copy with otak, okay, with brain, okay? Don't simply copy just because you are nearing the deadlines. Okay, try to copy and understand the question or the answer. And lastly, please do the project. Please submit the project. Okay, some students fail because they rely on their friends to submit the project, but the friend didn't submit. So because of that, the whole group got 0. So please submit the project. Okay. All right. So any question before we start the first lecture? Any question? Maybe you want to drop now to give way to students who want to do manual registration. You can do it now.
No question.
Okay,
Doctor.
if you don't have any question, we will start our first lecture. Okay. Okay, so chapter 1 is about basic control system concept. So the title of the subject is automatic control. So what is control that we are going to learn? Is it the remote control that we use in our house to switch channel in Astro? Is that control? Okay, or is it control macho? Is it the same? Okay, so control system in mechanical or in engineering is basically uh, a thing that is add or put in the system to make sure that the system is stable. Okay. For example, uh, I give you example for like a car. For example, when you drive a car, your car tend to vibrate, right? So the vibration of the car, if you ask mechanical technician at bengkel creator, for example, at workshop, they will say that the vibration is due to misalignment of the car. So when you have the car misaligned, then it will cause vibration. Then this vibration is the instability in the control system. So you need to do something, okay? Maybe adjust the alignment or put some controller to automatically realign the car, maybe, okay? So this is the concept in control system, okay? To control the stability of a system. Okay, so in this chapter, after completing this chapter, you guys will be able to define a control system and describe some application, and also describe the basic features and configuration of control system, such as input, output, plant, open loop, closed loop, etc. Number 3 is to describe control system analysis and design objective. And lastly, describe a control system design process. Okay. So control system is an integral part of our modern society. Okay. There are many applications of control system especially in engineering. Okay. So mechanical engineering, for example, the car that I mentioned just now, in computer science, in electrical engineering. So computer science, we use control system. For example, like when you learn programming, you use if else, for example, for loop. So that's control, okay? Control part of control system. For electrical engineering, you are using controller to control, for example, like robots, robotic hand, for example. So same for instrumentation engineering. And in chemical engineering, you are putting control system to control the plant, how the plant will stop running after certain times, for example. And there are many more examples if you look at online, Wikipedia, for example. So this is the basic example of a control system that you are using probably now. I know maybe some of you are in the toilet watching this Google class. So this is a liquid level control system, okay? Our flush system in toilet. So if you look here, in this system, you have this ball here. So this ball will control the level of water in this tank. So when you flush and there's water flowing out from this valve, when water flowing out, this buoy, will drop and then opens this valve. Okay, when this valve is open, then water will flow into the tank and filling the tank. Okay, when the tank fills, then this buoy will raise to the original height and closing the valve. Okay, so having this buoy, it acts as a controller for this liquid level control system. Okay, so here you have the inflow, outflow controller and buoy as the components of the configuration for the control system. And this is another example of a control system. This is an electric furnace. Okay, electric furnace is used to melt metals, for example. So you put metal in this electric furnace, and then the system will heat the furnace up to certain temperature until the metal is melt. And this thermometer measures the temperature inside the furnace. So let's say when the temperature drops suddenly, then the thermometer will detect the drop of the temperature and then will send signal to the system, to the computer, to ask the computer to increase the temperature back to normal or back to the values that you put. Okay, so the value you put is here. Okay, you put the values of temperature you want in this program input. Let's say you put 100 Kelvin. Then let's say the thermometer detects the temperature maybe 70. So the system, the thermometer will tell the system to increase the temperature back to 100, okay, by adding 30 Kelvin more. So the system will ask the heater to increase the heating process to make sure that the temperature increase back to 100 Kelvin. Okay, so the reverse process also the same, meaning that if let's say the temperature detected by thermometer is 110 Kelvin, then the system will know that it needs to drop the temperature back to 100. So drop -10. Okay, so the system will tell the heater to slow down heating. Okay, so that the temperature will drop back to 100 Kelvin. So this is how a control system works. Okay, and this is another example, a robotic hand. So if you look here, this is the robotic hand. So the robotic hand will pick up this block and put the block here, okay, at the work machine. So how this hand pick this block and put on this work machine? It is detected by this television camera. So as the robotic hand moves, the television camera will sense the location of the robotic hand. Let's say the robotic hand move far away from the block, then the camera will detect the movement and tells the controller to ask the robotic hand to move closer to the block. Okay. So this television camera will act as a sensor. So it will sense the movement of this robotic hand. If there is a wrong movement of the robotic hand, then the camera will tell the controller, and controller will ask the robotic hand to move accordingly. Okay. So we have looked at three examples of control system. So what is control system? Okay, so we baru nak define, okay, the control system. So a control system consists of subsystems. So subsystems and processes or plants assembled for the purpose of obtaining a desired output given a specified input. So from the previous example, you give input to the system. For example, like the furnace, you give input 100 Kelvin. So the desired output will be 100 Kelvin as well. But there might be some changes in the way, okay, in the middle, before you get the output. Maybe the temperature increase or decrease. So the control system, the subsystem and also the process will try to make sure the output is the same as what you desire, okay, as what you give from the input. Okay, so that's the purpose of control system. So here you have the input. So the signal will go into a box. So the box consists of control system and will give an output signal output. Okay, so we give out the output. All right, so in control system, there are 4 elements, okay? There are 4 elements for any given control system. So the first element is the input. So you must have input for your control system. Input, for example, just now is the 100 Kelvin you gave to the furnace system, okay? So that's the input that you want, okay? You desired the system to produce the output later. And then the output is the things, the outcomes that you want from the control system, or the actual response from the control system. So the output you want is 100 Kelvin, but sometimes because of problems in the system, then the output may be more or less than what you want. For example, the 100 Kelvin just now, maybe the output can be 70 Kelvin or 110 Kelvin. So it is not according to what you desire. So that's why you have a control system to adjust, okay, the difference to make sure the output produced is the same as what you desire, okay. And also the third component or the third element subsystem. So subsystem is anything, any system in the control system that helps controlling the output, okay. So it is any system, any other components that help in controlling the output. And lastly is the plant, in which the output is the one to be controlled, and it is the things or the system that perform the particular operation, okay. For example, the electric furnace, the plant is the furnace, okay, because it is the place where have everything happening, okay, the heating happening in the furnace. So the furnace is the plant, okay. Okay, so there are 2 types of control systems, okay. First type is open loop, and the second one is closed loop. So closed loop also known as feedback control or automatic control. So we will get back to this in following example, what is open loop and what is closed loop. So open loop is a system that when the output is not compared with the reference input, meaning that for example here, the example given here is washing machine. So for example, washing machine is when you try to wash your clothes, you set the the timing on the washing machine, maybe 2 hours for the washing process to complete. But let's say suddenly your friend stop the washing process, and then you realize that the washing process has been stopped, then you continue the process. Okay, so the cleanliness of the clothes is not the same as when the washing process does not disturb. Okay, does not disturb by your friends. So when the washing process is disturbed, then the cleanliness might be not as clean as when the system is not disturbed. So when this happen, then you know that the washing machine is an open loop, meaning that it does not measure the cleanliness of the clothes. So let's say the washing machine measure the cleanliness of the clothes, then it will wash slightly longer because the washing process has been stopped. So to compensate for the stopping of the machine, then it will wash longer. But because it does not detect that, then it will keep continue washing according to the time that stop. Okay, that was stopped by your friend. So in an open loop system, you require calibration. Calibration means that, for example, the washing machine, if it stopped, then maybe you need to restart the washing process again, or maybe you need to calibrate the timing to add more time on the washing process. And also when there is a presence of disturbance, for example, your friend just now, then the system will not perform to the desired task. Okay, it will not perform as what you want. So open loop system tend to be uh, disturbed. Okay, I mean tend to change in performance when it is disturbed. And a closed loop system basically is different from open loop because the input signal and the output is measured. Okay, and then when it is measured, it will fed to the controller so as to reduce the error and bring back the system so as to produce output to what you desired. For example, if the washing machine is a closed loop, then it will measure the cleanliness of the time to make sure that the clothes. So for a closed loop, the different between closed loop and open loop is that in a closed loop you have a subsystem, an additional subsystem called a sensor. So a sensor basically it detects the output, and then it will tell the controller to measure the output, measure the difference between the output and the input, and ask the controller to either increase or decrease the process. Okay, for example, the electric furnace just now, if there is a difference in temperature, then the system will either increase heating or reduce the heating of the heater. Okay, so that's a closed loop because it has a sensor. So sensor is an important component for a closed loop system. So this is another example of a block diagram for open loop and closed loop control system. So for closed loop control system, you see here compared to closed loop control system block diagram is that it does not have this error, okay, the feedback error here. So for a closed loop system, you must have this feedback arrow, okay? And you must have the sensor component in the feedback, okay? In the feedback arrow. And also, in a closed loop system, you must have this thing. So this thing, we call it summing junction. So we will learn more about summing junction in chapter 3. But you must remember that for a closed loop system, you must have summing junction and the feedback arrow, okay? And sensor. You must have these three things. If you don't have these three things, then maybe later if you want to answer the quiz or final exam or diagram, it has all the necessary elements for the control system. So the first element is the input. So this is input. And second one is this output. Since this is an example of lighting in a room, so the process occurred in a room. So the room here is your process or plan, okay? Also is part of the subsystem, okay? And for the closed loop system, the difference is that it has sensor and feedback arrow, okay, and summing junction. All right, so this is we go back to the example for the toilet flush system. So the top one, the figure A is the system when is the flush system when it is an open loop. So here basically when you flush out the water, so the water will flow out, then it will not automatically filled by the incoming liquid. Okay, so you need to manually open the valve. Okay, so every time you want to use this system, when you flush, you need to open the valve to fill in the tank. So if you don't close this valve, then water will keep filling in until melempah keluar. Okay. So to avoid the water from keluar or melimpah, then you need to turn off the valve. So it's manual, meaning that you don't have a controller to automatically close the valve when the tank is filled with water. So the second, the figure B shows when the system is in a closed loop, okay, closed loop arrangement. So here you put a sensor, which is the buoy or float, and also something, a controller that connects with the incoming valve. So when you flush out the water, then the water will empty the tank and the buoy will drop. So when the buoy drops, then the controller or the pivot will open the valve and the water from the input will flow into the tank. Okay, and the flow of water will continue until the tank fills by water until the buoy reach to a certain height, okay, or certain level. So here the buoy reach this point, and when the buoy reach this point, it will close. It will ask the pivot to close the incoming valve. So the water will stop flowing into the tank. Okay, so this is the difference between closed loop and open loop system. Okay, so in the slide, I already gave you the differences between open loop and closed loop. So generally, closed loop are more expensive because you are required to put more components, and the most expensive component in the system is the sensor. So because you need sensor, then it becomes costly. Okay, and then another differences is the stability. So in open loop system, the stability is not a major issue, but for closed loop system, there will always be stability problems. So we will go into stability later in uh, chapter 3 and so on. So basically when you have stability, then you will have oscillation, okay, or changing in amplitude. So you don't want oscillation to occur in your system because it may cause damage. For example, like the car example, the misalignment of your car. So when the car keeps vibrating, then it will cause damage to the car. Okay, so you need to remove the vibration. And for open loop system, it is sensitive to disturbance. Uh, the example that I give to you is the lighting in the room. So when you have external light, then your room will be extra brighter than usual. But if you have a closed loop system for the brightness of room, then the system will dim the light when you have an external light. Okay, so closed loop system is not sensitive to disturbance. Calibration, closed loop does not require calibration, but open loop you need to calibrate every time. For example, the flush system, you need to manually open and close the incoming valve. So that's the calibration. Okay. All right. So let's do some exercise. I know you guys are having your breakfast. So meanwhile, while you are having your breakfast, can we go and do this exercise together? So this is an example of a liquid level control system. So from this system, what do you think is the plant or process? Okay, anyone? I give extra marks for those who answer. Anybody? What do you think is the plant? Okay, tak nak markah lebih. Okay, so the water tank is the plant. Okay. And the output is the outflow of water. And the input is the inflow of water. The subsystem is the controller and the float. And the actuator is the pneumatic valve. Okay, so for temperature control system, the electric furnace. So what is the plant or process? So the plant is electric furnace. The output will be the furnace temperature. The input is the value of temperature you put into the computer. The subsystem are the remaining components in the control system, and the actuator is the heater. And lastly, the robotic arm. So the plant is the whole thing, basically the work machine and peripheral equipment. The output will be the movement of the robotic arm. The input is the movement that you want, that you input into the system. The subsystem is the controller and the actuator, the robotic arm, and actuator is the robotic arm. All right, that's it for this chapter. So I want you to take this exercise as your take this question as your exercise. Okay, so this is past year question. So try to do it and discuss is from past year as well. So for this, you can Google it, the answer. Okay, you can find this in the website. Okay. Okay, so for today's quiz, I want you to answer this quiz and submit it before 8 a.m. Wednesday. Okay. And this quiz is 2% for those who submit before 8 a.m. Okay, don't submit late. I don't accept late submission, and no request for those who don't know about this quiz. Okay.
Doktor,
Yep.
nak tanya yang slide ni ada dekat kalam ah?
Ada kot, tapi lain sikit.
Lain sikit oh. Quiz ni ada dekat kalam?
Tak ada.
So kena, okay.
Alright. So any question?
Sir, nak tanya kuis ni hantar bila last? Sorry tadi tak berapa jelas.
Rabu pukul 8.
Okay, thank you.
Slide tak boleh bagi dalam group sebab ada quiz. Okay, any question before we end our lecture for today?
Dah ada very quiz John.
Tak ada question.
Okay, so please try to do this quiz because this is from sem lepas punya soalan. Okay, student tak boleh jawab. So please try to understand the question and try to discuss with your friend. Okay, sebelum tiru discuss dulu. Okay. Okay, so that's it for today's class, and inshallah we will meet again on Wednesday. And for those who haven't registered, please try to register OR first. And this Wednesday, if you cannot register OR, then we will go to manual registration. Okay. All right. Bye-bye. Assalamualaikum.
Bye doktor.
Thank you doktor.